Hi, hello, and welcome. We are officially reaching the halftime in the world of LLM routing. If you've been following the space for the last few years, you know that LLM routing has mostly been treated as a traditional networking problem. It was a gateway engineering challenge for the new AI era. The goals were clear: reliably send requests to a model, stream tokens back steadily, and keep your latency, cost, and availability within a set SLA. And here is the thing: it worked. It, in fact, it worked too well. It worked so well that the entire process has been platformized and standardized into a reusable industrial recipe. But if it works, why am I saying we are only at half time? What is suddenly different? In one sentence, models are exploding in number, and that traditional AI gateway recipe is becoming a commodity. It's getting hard to say, I built an AI gateway, because you quickly realize what you built is almost the same thing everyone else has built. When a general recipe solves the core problems, incremental improvements get steamrolled by standardized pipelines. The game shifts from solving problems to defining them. I think the second half of LLM routing starts right now, and it starts with the realization that when innovation gets squeezed out of the infrastructure layer, we have to rethink what routing actually means in the AI era. To understand where we are going, we have to look at the first half. If you look at the winners of the last few years, they weren't selling fancy esoteric techniques. They were selling a complete productized capability set. They built the AI gateway. This looks just like a traditional API gateway. You unify backend services, handle authentication, manage token quotas, rate limiting, circuit breaking, retries, and failover. On the inference side, you add load awareness, queue priorities, and prefix caching. These tools solve the core problem of the first half, making LLMs behave like a manageable backend service. But notice the pattern. In this model, routing decisions are based on the system state. Things like health, load, price, or tenant policy. Models are just endpoints, requests are just packets. That was perfectly reasonable when we were just getting started. Fast productionization and reliability were the value, but now we are facing a brutal structural force: homogenization. If you study multiple AI gateways today, you reach a very unromantic conclusion. They all look extremely similar. Innovation has been compressed into plugin lists and product packaging. You always see the same recipe: a unified entry point, usually an OpenAI style API, token based governance because finance needs to close the books, the reliability of retries, fallbacks, and circuit breaking, and standard observability. Once this recipe is established, the industry enters a phase where the standard recipe crushes incremental methods. So the question becomes, if the first half recipe already works and is standardized, what are we playing for in the second half? Are we just adding more items to the plugin menu? I don't think so. And that's because the nature of what sits behind the routing layer has changed. In the traditional API world, backend services are deterministic. You call an API, it succeeds or it fails. In the LLM world, backend services are generative. They are increasingly agent like. They reason, they act, they call tools, and they change the external world. The backend is no longer a passive service. It is an entity that makes decisions, makes mistakes, and can self reinforce. If you treat routing as pure packet forwarding, you are effectively trying to govern a thinking, acting system. With the abstraction of a transparent proxy, it doesn't work. The second half recipe requires an upgrade. We need to make decisions more deliberative. We need to bring the concept of react, reasoning and acting, into the routing layer itself. The core of React isn't just about writing a longer chain of thought prompt, it's about interleaving reasoning and actions. Reasoning helps planning, actions connect the system to the environment. Bringing this into routing, and you get a direct conclusion. Routing doesn't just make decisions based on static signals. Routing should think first, act, and then decide. It needs intelligence. The actions here can be concrete. Maybe the router decides to retrieve context first. Maybe it runs a verifier. Maybe it asks a small language model to clarify user intent. Maybe it runs a safety check on a high risk span. It might even do a lightweight probe using a cheap model to test for uncertainty before deciding whether to escalate to a stronger, more expensive model. In other words, second half routing is not just a traffic router, it's an agent brain doing decision time compute. This also means we need to embrace search, backtracking, and self evaluation. Think about the tree of thoughts method. It argues that standard inference is just a greedy left to right process, but complex tasks they require exploration. If you bring that logic into routing, we redefine what a route is. It's not an if else statement, it's an explorable strategy tree. For the same request, your router might expand multiple candidate paths. Path A is a direct answer from a fast model. Path B involves retrieval. Path C uses a strong reasoning model plus a verifier. Path D asks the user for clarification. The lesson here is don't pretend you can one shot the decision. Allow the routing layer to do a bounded search using self evaluations to choose the next steps. Routing shifts from splitting traffic to planning. And finally, routing needs feedback and reflection. Reflection with an X is about decoupling, getting stronger from updating model weights. You don't always need to fine tune. The system can ask task feedback into language based reflection and then write it into memory and make future decisions better. This is not the most critical step of the second half. The routing system must be reflexive. If it isn't, it will keep repeating the same class of errors, and the feedback sources are real. Tool call failures, factuality checks, user complaints. These aren't just training data, they are online signals. And here is the bridge to the future. The first half was unified entry, governance, reliability, and observability. The second half is semantic signals, think, then decide, tree search, and reflection. There is actually an even deeper driver here, something about anthropological collective intelligence. Human intelligence has never been about solo brilliance, it's a composition of collective intelligence. Teams have a measurable collective intelligence factor that outperforms individual IQ. If we apply that lens to LLM systems, we see a natural analogy. We are moving from one big model fighting alone to a collective system of multiple models, tools, verifiers, and memories. Routing is the organizing mechanism of that collective intelligence. If you treat SLMs, LLMs, reasoning models, and verifiers as different experts, then the task is no longer pick an endpoint. It becomes a classic collective intelligence problem. How do you get diversity and aggregation without groupthink? That is why I say second half routing is more like a brain. It's organizing an intelligent group. This brings us to the core change. In the second half, the object of routing shifts from endpoints to behavior. You are no longer just choosing which model, you are choosing how the system should behave. Should we enable reasoning? Should we be conservative or aggressive? Should we force citations? If first half routing was traffic control, second half routing is an intelligence control plane. This implies three specific directions for implementation. First, semantic routing. We need to capture high value signals, intent, uncertainty, risk level, and then use them in a loop. Reason about what we are missing, act to fill the gaps, and then decide. Second, cross LLM intelligence. This is about like making these experts collaborate. Different models excel at different subtasks. The second half is about enabling them to collaborate with minimal coordination overhead. And third, guardrails. In a collective system, guardrails aren't just an add on, they are the team norms. It's about permission audits and traffic session level state so that attackers can decompose harmful intent into harmless looking pieces. So, this leads to one final hard question evaluation. As models multiply and routers get smarter, how do we evaluate an intelligent router? For a traditional gateway, it was easy latency, throughput, error rate. But if routing is picking behavior, we have to measure good system intelligence. We need to measure task completion rates, multi turn efficiency, and stability. We need to measure whether the system becomes more reliable under long term feedback. We are already seeing early evaluation systems emerge that put routers under the same dataset and difficulty tiers. This signals that routing intelligence must be measurable, otherwise, it's just a castle in the air. So let's wrap it up. Looking back at the first game, we turned LLMs into callable, governable services. We converged on a recipe, homogenization then arrived. The second half game is different. We have to admit the backend has changed. It's uncertain, it can lie, and have to move reasoning and acting into routing decisions. We have to move search and backtracking into the strategy. We have to upgrade from solo intelligence to collective intelligence. In the first half, routing transported requests. In the second half, routing builds collective intelligence. Welcome to the second half.